in the book, actually. This is marker 1-6. These types of equations are not necessarily quadratic. They're not necessarily linear, but they do share some attributes with both of them. They look pretty much horrible. They actually look incredibly horrible. So we'll start off with something simplistic. This is quadratic form. And quadratic form generally has this kind of look. Well, let's put that in there. Where n can be anything. Literally, it could be anything. It could be real, it could be imaginary, but we're not going to let it be imaginary. But it could be a fraction, and it could be integers, it could be whole numbers, it doesn't matter what it is. So the pattern here is this. The middle variable and the beginning variable have something in common. They're both x to the n. Except the first one has this extra 2. So how do you go from x to the n to x to the 2n? Raise it to a power of 2. You square it. So the pattern here is, if this is a quadratic form, if you take the middle variable and square it, it should become the first variable. So let me ask you this. Is this a polynomial in quadratic form?
Yes.
Really? Take the middle variable, square it. Does it come out to be the first one? No. So this is not quadratic form. Just because it has 3 terms is irrelevant. It has to be that middle variable. If you square it, it comes out to be the first one. So this one is not quad form.
You can't have 1.
Hmm?
You can't have 1.
What do you mean 1?
It can't be raised. It got to be more than 1. Raised to a power. Like more than like equal to 2 or something.
What, up here?
Not the second.
Oh, it could be anything. Let me give you an example. 4x minus 3 square roots of x minus 1 is equal to 0. Is that in quadratic form? Well, yeah. Because if I take that middle variable, which is square root of x, and I square it, do I get x? Yeah. So this is quad form. As long as that pattern works, you're perfectly fine. So to solve one of these equations is actually kind of easy, in a way. If I have 6x to the 4th plus x squared minus 2 is equal to 0, first off, is a quadratic form polynomial. The answer to that is, yeah. If I take x squared and I square it, do I get x to the 4th?
Yes.
Yes. Okay. So the first thing you're going to do is you're going to do a little substitution. I'm going to write it backwards. I usually write it u equals, but I'm going to write it as x squared equals u. I want to choose that middle variable, that x squared, to equal some other variable called u. Not u, the letter u. And then I'm going to square both sides. So if I square the u, I get u squared. What happens when I square x squared? X to the 4th. And that will always turn out to be the first variable. So far, so good? I'm just going to do a substitution, replacing equal value with equal value.
I don't get what this is.
Oh, hold on. This is just the step. This has nothing to do with anything other than I'm going to do something really cool. Huh?
I'm just trying to wrap my head around that.
What?
How to.
I'm just choosing x squared to equal this other variable
Yeah, I
called
get
u.
that.
Then I'm just going to choose to square both sides. Because I know in a quadratic form, if you take that middle variable and square it, it becomes the first one. That's why this technique works. All right, so wherever I see x to the 4th, I'm going to replace it with
U
u squared. So this becomes 6u squared. 6u squared. Plus, wherever I see x squared, I'm going to replace it with?
X to the 4.
No, wherever I see x squared, what it's equal to is u minus 2 is equal to 0. What's nice about this green equation compared to the blue one is this one is a quadratic. Literally, because it's raised to the 2nd power and it has 3 terms. How do I solve a quadratic? Go through the methods. Method number 1, factor. Always try to factor first. If it doesn't factor, then you go into the other ones. So 6 times 2.
It's 12.
It's 12. Factors of 12 and subtract up to 1.
3 and 4.
3 and 4. So this is going to become, we'll keep it in the same color, 6u squared, 3u, 4u, minus 2. Okay, what kind of 3, what kind of 4?
Negative 3, positive 4.
Negative 3, positive 4. GCF of the first 2. 3 u, left behind.
2 u minus 1.
Sound like a robot. GCF of the second 2?
2.
Positive 2. We want to get that sign in there. Left behind, of course, is 2u minus 1. And it's equal to 0. See, it's almost done. And then we get down to 2u minus 1 times 3u plus 2. Remember, we're kicking out that 2u minus 1. And this thing is equal to 0. Okay. What's the next step?
Equal both of them.
Set them both equal to 0, and we're going to get one of them as u equals a half, right? Add 1, divide by 2. The other one's going to be u equals
3 with 2 3.
negative 2/3. Subtract 2 and divide by 3. Problem. I've solved the green equation. Awesome. Except for one problem. I'm not trying to solve for u.
And you're trying to figure
You're
out.
trying
I'm trying to figure out what x is.
Right.
So what I have to do is do the substitution in reverse order. So we have to go back to x's. So here I have u equals 1/2. What is it in terms of x?
X squared.
Yeah, because I let u equal x squared. So you go back to the beginning of the problem, and you do the substitution the other direction. I replace x squared with u. Now I want to replace u with
X squared.
x squared. So the first one becomes x squared is equal to a half, and x squared is equal to negative 2/3. Yay.
Okay, so the original problem, like what you would give us,
You've
figure
got to
it
solve for
out.
that variable.
Yeah, but you would get, but that right there, those
I give you
two
the blue.
things. You give me the blue. So,
I give you the blue.
so we have to figure out the bottom.
All the green. All the green is your work, plus this blue over here. This is why I got in arguments with the other class, because they don't understand the idea of substitution. Substitution, all you're doing is replacing equal values with
Yeah.
equal
But
values.
how do you know?
This is the technique. This one is always going to work if it's in quadratic form. You choose the middle variable, set it equal to u, square it, and you get the first one.
So x squared is the middle variable, x to the 4th is the first variable,
Yeah.
period.
Yeah, end of conversation.
Okay, so you
So then
always
when-
square. Well, not
Yes.
always square.
Yes.
the middle. If it's
Always.
But how
This,
do you,
this step, this green step in the middle, always.
how do you keep
Okay.
track of it?
By writing this down.
No, that's not what I mean, because down there, and the doctor right there, I just can't get them together. Hold on a minute.
This is the basis of algebra.
No, I don't do
This
that.
is the basis of algebra, replacing letters with letters.
Right.
Replacing numbers with
But where
letters.
does, you've
Where's
got
what?
2 u's, you got both of those are u's down
Yeah.
there. How do you
When you
signify-
solve a quadratic, you get x equals 2 different numbers.
How do you signify which one's u and which one's u2?
Yeah.
There's no YouTube.
There's just u. When you solve a quadratic, you get x equals and x equals. How do you determine which one's x1 and which one's x2? I've never said that. They're both x. It's either u is equal to 1/2 or u is equal to negative 2/3. The key word between these two is
Or.
or. That means both of
Oh.
them are
One
my
or the other.
solution.
Oh, okay, there you go.
It's just confusing.
I know. For some reason,
No,
people
because I
don't
was
like this.
expecting one to
Keep
be
it in
the
x
other.
and people are fine. I switch over to another variable and everything falls apart.
Okay,
Well,
so all the quadratic equations, you're always going to square the middle term.
Every quadratic form has those two steps.
Okay.
Choose u to be the middle variable and then square it.
Okay. So if it was like 2x squared, you would do 4x.
Don't touch the number.
Okay.
The
Just the
variable.
variable.
Just the variable.
Okay.
Okay, so how do I solve the first one? I'm not done because I have to solve for x.
So
Take square root.
Take the square root. Now, when you take the square root of both sides of an equation, the answer becomes x equals.
Square root of 1.
Uh,
Nah.
It's like your brains fall out at this point.
Fraction, right?
It's the same thing as that. Remember the completing the square I did over here? And we square rooted both sides of the equation? And the first thing you write down is,
Plus or minus.
thank you,
Oh.
plus or minus. You square root both sides of the equation. You better tack that in first. Square root of 1 over the square root of 2.
Oh, 2. Okay.
Did you just say 4?
No, I didn't. I said 1.
Try to get me bad. Oh. Should I leave it like 1 over square root of 2?
No.
Heck no. You can't divide by a radical. So how do I rationalize that?
Multiply by the
No, not that hard.
No, you multiply by I.
There is no I here.
Multiply
Top and bottom by
2
2 square root
out.
of
square root of 2. Top and bottom.
Oh, yeah, that's
Lord.
right.
Brain. So x equals plus or minus.
So
One square root of 2 over 2.
Square root of 2 over 2. 1 over the square root of 2 is the same thing as square root of 2 over 2. If you ever get to pre-calculus, you leave it as 1 over square root of 2.
Oh.
But because we're in college algebra, square root of 2 over 2. Okay, this side. What do I do to both sides?
Square root.
Square root both the top
and bottom.
and the bottom over there, and the left and the right. And the square root of x squared is just going to give us x, and it's equal to,
Plus or minus.
thank you,
I
I square root of 2 over
square root of 9.
square root. Why do you keep doing that?
Okay.
You're like squaring it. I'm square rooting it.
Okay.
Can't leave a square root of 3 in the bottom. Multiply top and bottom by
3 square root of 3.
square root of 3. And we're going to get x is equal to plus or minus I
Square root of 6.
all over.
3.
I was waiting for you to say 9. X is equal to now square roots of 2 over 2, negative square roots of 2 over 2, positive I square roots of 6 over 3, negative I square roots of 6 over 3. How many answers?
Is that it?
4. Degree of the polynomial?
4.
Kind of cool if you think about
Um,
it. What?
Nothing. I just
Okay.
thought that was neat.
Oh.
Okay, so I had to watch that. Now I gotta write down.
Erase it as quick as I can?
No.
Let's try this one. This is the one I had argued with the other class. The other class got that first one fine. They didn't argue too much. Then I put this one on the board. And they wanted to do it differently for some reason. 2/3, y to the 2/3 minus 12, y to the 1/3 plus 32 is equal to 0. It's a horrible equation.
I have a question real quick going back to this one. I know real quick. I thought you said x equals plus or minus I over square root of 6 over 9. Did you
No. I said that because he kept saying 9.
Gotcha.
Square root of 3 times square root of 3 is just plain old 3.
Yeah,
I was waiting for him to say 9.
Oh, okay.
So you heard half the conversation.
I did because I was writing.
You can't write in here?
No, see, yeah, that's my problem.
Really?
Yeah, I can't. I have to watch if I want to understand it correctly. That's why your videos are good.
I'm gonna try. Alright, is this quadratic form?
Yes.
How do you know?
Because the first one is got a 2 on it.
No, don't go by that. Because if you take the middle variable and you square it, does it become the first one?
Yes.
Yeah.
Off to the side. Y raised to the 1/3 squared. Power to a power you multiply. And 1/3 times 2 is
2/3.
2/3, which is the first one. So this is quadratic form. Now, since it's quadratic form, we can let the middle variable equal a new variable called u. It's never going to be anything different than u. If you want, you can put v. I could care less what variable you use. Just don't use x, y, or z, because obviously this one has y. Now, what do I do with these two?
You raise them square.
Square them. So y to the 1/3 squared, we've already done, is y to the 2/3. U to the first squared is u to the second. Yay, I squared both sides. Now, after you do this step, the equation changes into u. Where you see y to the 2/3, you're going to replace it with u squared. So I get u squared minus 12. Where I see y to the 1/3, I'm going to replace it with u, because y to the 1/3 is equal to u, plus 32 is equal to 0. Yay! Now, generally, I'm not going to have you do completing the square quadratic formula at this point. It's always going to be factoring. So factors of 32 that add up to 12.
4 and 8.
4 and 8, right? And this is a nice factoring. You get u4, u8, u2.
Plus 4 minus 8. Nah, it's minus both.
Minus both, because it's plus 32. They have to have the same sign. So we'll get down to u equals 4 and u equals 8. Yay! Keyword between these? Or. No way of being and, because you can't be both at the same time. Alright, but we're not trying to solve this for u, we're trying to solve this for y. So we have to kind of go backwards. What does u equal?
4.
No, it does not. No, in terms of y.
Oh,
Y to the
Minus 1/3.
You go back to this step, y to the 1/3. So where you see a u, you're going to replace it with y to the 1/3 is equal to 4. And over here, y to the 1/3 is equal to 8. How do you solve this equation?
Gotta multiply by something.
Multiply by something. What does 1/3 power mean?
It's a cube root
It's a cube root. So how do you undo a cube root?
by cubing it.
By cubing it. So I'm going to cube both sides. Now, if you don't believe that a cube and a cube root cancel each other out, look right here. How do you raise a power to a power?
Multiply.
What's 1/3 times 3?
It's 1.
It's 1. They're multiplicative inverses, so we'll get y on this side is equal to
1. Well,
64.
64.
64.
Notice there's no plus or minus going on here. This is a straight cubing. Perfectly fine. Alright, the other side over here, we'd also cube both sides, and you're going to get y equals whatever the heck 8 cubed is.
512.
512. So there's only two answers here, and y is equal to the set 64 and 512. Yay! This is easy.
Oh, okay. So that's all you do.
That's it.
Why did,
Go ahead, say it.
why didn't we go back
Oh,
and
okay,
plug
no, I
that
see
in?
what you did. You
Plug
just
what in?
Because you didn't have to go through all that square and this, you could.
I didn't have any radicals or
Yeah,
anything.
because you didn't have
fancy stuff.
radicals, so that's cut out like a half a page an inch.
Of course, this is a very simplistic problem, too. Wait
You
until the
only
next
have
one.
2 answers, so
This one only has two answers. You can't base it on that anymore.
Yeah.
Because it's a
It's
little
not-
confusing. But it's really because of the two up top.
okay.
But when you get into rational exponents, the rules don't follow
Okay.
polynomials really well.
Well, I didn't really get to watch that one because I was too busy copying it down now, so I'll just watch it when I'll
Here comes the bad one.
at the video.
Y to the 4/3 minus 10y to the 2/3 plus 9 is equal to 0. Why is this one bad? Alright, the first one I did of these, we square rooted both sides and we had a tech and a plus or a minus, right? And the reason we square rooted both sides is because the middle variable had a square. This middle variable has a square. Do you see it? Where is it? It's that 2 on top. Because that 2 is on the top, we're going to square root both sides of this equation. So this is another one we're going to end up with plus or minus. This one doesn't have a plus or minus because the middle power is not a square. It's just 1 over 3. If it's 2 over 3 or 4 over 3 or 8 over 3, we're going to have plus or minus. So if the top number in your U substitution is even, you're in trouble because you're going to have a lot of answers. So guess what? We're in trouble. We're going to have a lot of answers. So first step, is this quadratic form? In other words, if I take this middle variable and I square it, do I get the first variable? Notice I'm not talking anything about the coefficients. I'm talking about variables here. So when you square y to the 2/3, do you get y to the 4/3? Yeah, power to a power. 2/3 times 2 is 4/3. So that works. So then you go, let y to the 2/3, your middle variable, get replaced with u. Okay. And then square both sides. So if I square u, I get u squared. If I square y to the 2/3, I get y to the 4/3, which is the first variable. No. This step, if you're doing quadratic form, this is guaranteed first step all the time. The only time it gets tricky is after you substitute in the variable. You might get some weird answers. But the first parts of this, very simplistic. That becomes u squared minus 10u plus 9 is equal to 0. After you do a nice little substitution. Factors of 9 that add up to 10. Oh my god.
1 and 9.
1 and 9. That was really hard. So we get u9, u1, both of them minus. Therefore, u is equal to 9 and u is equal to 1. Yay! But now I have to go back to the original equation. So instead of u, since I don't want to solve for u, I want to solve for y. Well, I made it y again. I should have made it z. I want to solve for y, so what's u equal to?
1, 2/3.
Y to the 2/3. You go back to that first step. So this becomes y to the 2/3 is equal to 9, and y to the 2/3 is equal to 1. I'm going to rewrite this. It's getting a little low for me. So y to the 2/3 is equal to 9. Let's deal with that one. Here's a reason I'm writing it bigger. Alright, how do I solve for y?
You, cube.
You can, are you going to do it in pieces? I don't want to do piecemeal. How do you get rid of a 2/3 power?
Raise it to square.
Hold on, let's go back over here. This was y to the 1/3 and we cubed it. Why did we cube it? Because 1/3 and 3 are multiplicative inverses. What is the multiplicative inverse of 2/3?
3 halves.
3 halves. So I'm going to take both sides and I'm going to raise it to the
3 halves.
3 halves power.
Why did you do it in that one without the other one?
What do you mean? Oh, I did.
Oh, you just didn't write it? Okay.
I just didn't write it. Because I knew I was just going to cube the answer. But this one's a little, uglier. So on this side, 2/3 times 3 halves, that gives us y to the first power, better known as plain old y.
Why?
Okay. What the heck is 9 to the 3 halves power?
3.
What's the 2 mean in the bottom?
Square. I mean,
If the 2 is in the top, I would agree that would be square. But the 2 is in the bottom.
You divide by 2.
no, it's the.
Let's go back into exponential land. If you have a to the m over n, this is the same thing as the nth root of a to the m. Remember that bottom number becomes a radical?
That's what I wanted to
An index of a radical? So this is actually a square root. Uh-oh. What word did we just say?
Square root.
Square root. What did I just do to both sides of this equation then?
Square root.
I square rooted it. So what's missing?
Square root. Plus or minus.
Plus or minus. Remember I said that at the very beginning?
Mm-hmm.
I'm emphasizing it here. If your bottom number on both sides of this power are even, then you better tag in a plus or minus. Now, this is the square root of 9, which is
3.
3. What do I do with the 3 on the top?
Multiply.
So 3 times 3?
No.
You raise it to the.
You cube it. You cube it. So the square root of 9 is 3. 3 cubed is,
27.
so this is plus or minus 27. It's like pulling teeth.
So what now? Explain that.
What? If I rewrite this using this,
But we're not using it. So
Yes,
I don't
we
want
are.
it.
We
That
can.
confuses me. I want you to do it from that problem right there.
right here,
Yeah,
then the 2 represents a square root.
okay.
The square root of 9 is? The square root of 9.
3.
3. The top number is a cube. 3 cubed.
Gotcha.
27. But yeah, you can write this the square root of 9, and then you're going to cube it. It means the same thing. All right, the other one. Y to the 2/3 is equal to positive 1. This one's a little easier.
Do the same thing.
You do exactly the same thing. Raise both sides to the 3/2. The cool thing about this side is any 1 raised to any power is always going to equal 1. But there's something you better not forget.
Plus or minus?
I need that plus or minus. This is y equals plus or minus 1. Because we square rooted both sides of the equation. That is a square root when you write it that way. So my final answer is y equals, 2 answers from up here, 27 and negative 27. 2 answers from down here, 1 and negative 1. 4 answers.
I thought you was saying something like
Yeah.
He said it was
That's a lot of answers.
That's a lot of answers.
It's not-
Now, what is the most common mistake? Forgetting the plus or minus. Because people do not understand that an even bottom powered
This is square.
exponent,
Plus or minus 27.
you have to plus or minus it because you're square rooting both sides.
Okay, I'm writing that at the top of my paper. So the if the bottom
If you-
number's even, you square root it.
Yes. Or if you want to look at the beginning of the equation, if the top is even, you're plus or minusing eventually. But gotta remember it sometime, either at the beginning or at the end.
What
Or
are,
both would be preferable.
what are the chances of an equation like this rolling out and not having to
A plus or minus.
do? Yeah.
Well, I mean, that's the thing.
It's all about that, isn't it?
If this was 10/3, the front number, the front exponent, this would be 5/3.
Right.
I won't have to worry about plus or minus because the top number is odd. Because then when I do the reciprocal, it becomes 3/5, and it's not square rooting or anything.
Yeah, but like
It's only if that top number in the beginning is even, or when you reciprocate, the bottom number is even, you have to put the plus or minus. Go for it.
Okay, when we did, let's see, we did okay, the first one when we had the 1/3 versus the 2/3, why didn't you cube the second one? Why didn't we cube this one?
Where are you?
In the bottom answers down there, where
There?
it, yeah, we cubed it when it was 1/3.
Right. That's the thing. You could have cubed it, but then you'd have to turn around and square root it. Now, if you cube something, that makes numbers bigger, and then you have to square root a big number, and it gets kind of messy. So it's actually safer to use your reciprocal power. That way you can make it smaller first and then bigger second.
Well, if the bottom got an even number that doesn't have a square root. Well, doesn't have an even square root.
You mean a perfect?
Yeah.
Yeah, that gets a little trickier. Like, say if your answer here was 8, then 8 to the 3/2 power is horrid. Because the square root of 8 is 2 squared root of 2, and then you have to cube it. And then you're going to get, 8 in the first slot, and then you're going to get a 2, and then a square root of 2, so it's 16 squares of 2. How many of you know how to do that? Just, mine are going to be perfect. I set it up already that they're perfect.
Oh, okay.
So if you end up with something like, you factored this and you ended up with 8 and 2, you did something wrong. Okay. Other types of equations, kind of backtracking a little bit. Absolute value. Absolute value equations. Now if we go back to, I think it was like the first or second day of class, I defined for you what it means to be an absolute value of a variable. So the absolute value of x had a split if x is positive and if x is negative. Remember, to read those two statements I just wrote on the board, the top one is x is positive, the bottom one is x is negative. Do not read it x is greater or equal to 0 because that means absolutely nothing to most people. Alright, so if x is positive, what happens to the absolute value of x? It stays the same, so that just becomes x. If x is negative, I need to take it out so that it is positive. So how do I change x into a positive number? Multiply it by
Negative
negative 1. So this becomes negative x. All right, now we're going into the nitty-gritty of algebra. A lot of people see this and go, the x has to be positive or the x has to be negative. And that's not what this is saying. It's saying the number has to either be positive or the number has to be negative. It's not the variable x itself. So another way of writing this is kind of weird. This is a much more generalized idea. Whatever is inside of the absolute values, if it is positive, you leave it alone. Whatever it is inside the absolute values, if it happens to be negative, you take whatever it is and multiply it by a negative. This is the same definition as this. It's just that people see the x's, all the x's that you see in any algebraic expression. This is much more precise because it's saying, I don't care what's in here. I'm going to do it to the entire thing. And this is really, really important to be able to see it in this fashion. Why? Well, because that's the way it's going to look on your questions. Now, I do mine a little bit different than the book. I go by pure definition. They do shortcut. I hate shortcuts. So, for example, if I gave you an equation that looks like this, the way you need to look at it, the way your eyes have to actually see it, is this is your number. 2x minus 3 altogether is your single value. And that single value is either going to be positive or it's going to be negative. It's going to be one of the two. So what you do is you assume that it's positive and you assume that it's negative, because it could be anything. So this gets split into two pieces. You're going to assume that 2x minus 3 is a positive value. And see what happens for positive values of 2x minus 3. And then you're going to look at it as 2x minus 3 could also have been negative for the correct choices of x. It could either be positive or it could be negative. All right. So if the number inside is positive, what do I do with it? Well, by definition, I do absolutely nothing. I just drop the absolute values and write it down. So this becomes 2x minus 3 is now just equal to 7. A nice linear equation. Okay. Most people get the first part. What do most people forget? The second part. You have to understand that if you see absolute values, you're going to get two answers. A positive part of the answer and a negative part. Not necessarily the positive answer or negative answer, just you're treating the inside as a positive number and a negative. All right, if it's negative, by definition, you're going to take the insides and multiply it by a negative, or a negative 1 if you want to think of it that way. So negative times 2x minus 3 is still equal to 7. That's by pure definition of what it means to be an absolute value. All right, we can solve the first one. Add 3,
2.
divide by 2. So this one gives us x is equal to 5. All right, over here, you have two choices. You can take the negative and float it to the other side. That's what the book does. Or you can take the negative and distribute. That's what I do. So this is negative 2x plus 3 is equal to 7. All right, now what?
Subtract 3.
Subtract 3, you get negative 2x is equal to 4. And finally, x is equal to
Negative 2.
negative 2. Oh, God. We can check our answer. Take 5. 2 times 5?
10.
10 minus 3?
7.
That works. And if I take negative 2 times 2?
Negative 4.
Negative 4 minus 3?
Positive 7.
It's negative 7. Then you take the absolute value and it becomes positive 7.
Ah.
So both answers are going to work. We get x equals 5, and we get x equals negative 2 as a solution set. Yeah, it is kind of fancy. Okay. Let's try this one.
This makes it harder too.
Sure. Actually, let's put a 2 way up front here, too.
Sure.
That's probably as hard as I can make it. That we're going to make it. There are equations that have multiple absolute values in them, but they're very tricky. Okay, so what should I do first?
Put your positive and negative sign.
Well, let me ask this silly question. Can I distribute the 2?
No.
Yes and no. You're not supposed to. I highly suggest that you don't. Especially the negative. I think a positive won't affect it too much, but a negative one will. So just leave whatever numbers outside, leave whatever numbers are inside. Don't mix and match them. So what should I do first?
Get it by itself.
Get what by itself?
Absolute value.
Get the absolute value by itself. So what do I need to move?
You minus the 5 first, right?
Subtract 5 from both sides. And that'll leave us with, 2 times the entire absolute value of 4 minus 3x is equal to 5.
And divide by 2.
And divide both sides by 2. So basically you're treating the absolute value as an individual variable, in the linear sense. And we get down to the absolute value of 4 minus 3x. Make sure you draw your absolute values kind of long, because if you make them short, they look like 1. And then I've seen people read this as 14 minus 3x instead of 4 minus 3x is equal to 5 halves. Now what?
Then you plus or minus.
You
Make one
Well, don't make
positive.
it plus or minus. You're assuming the inside's positive or you're assuming the inside is negative.
Right.
So if it's positive, what's it look like?
4 minus 3x equals 5x.
And if it's negative,
You said negative 4. Okay. 4 minus 3x.
oh,
Plus 3.
I was going to distribute it.
Okay.
So negative 4
Plus 3x
plus 3x
equals
is equal
5x.
5 halves. Whatever you do, don't change both sides of the equation. Just change one side. How do I solve the first one?
Subtract 4.
Subtract 4. See, I don't like that fraction. I don't like fractions.
Multiply by 2.
Multiply everybody by 2. So we get 8 minus 6x is equal to 5. That way I don't have to worry about common denominators and all that fun stuff. Subtract the 8 across and you get negative 6x is equal to
Negative 13.
what?
Negative 3.
Right, negative 3. Divide both sides by
6.
negative 6 and you get x equals,
1/2.
and if anybody says 2, you're in trouble, it's a half.
Yeah.
Alright. The other side, I would do it the same way. Multiply everything by 2 and you get negative 8 plus 6x is equal to 5. Then add 8 to both sides and we finally get 13. So you get 6x equals 13. And divide both sides by 6 and you get x equals 13, 6.
I must have did it the wrong way. Because I did it before you did it.
Oh,
And I got the same.
yay. Be careful. I have one to show you after this. X equals a half and 13, 6. Notice both answers are positive. I'm not saying that the answers are positive and negative. I'm saying the number on the inside of the absolute value is positive and or it's negative. It can't be
What
and
dictated
or
that?
it's negative.
What dictated, why'd you make that point? What dictated that?
What dictated what? That the answers are positive?
Yeah.
Nothing. It's just the way they worked
Just
out.
haven't changed.
I've seen people before, they see my plus and minus up here and they think this has to be a positive answer and this has to be a...
Negative answer.
It doesn't have to be.
It haven't changed. All right.
They both could be negative. It doesn't matter.
It is what it is. All right.
All right. This problem I'm going to write on the board, you have 5 seconds to solve. 5 seconds. Ready? Example. 2x minus 5 is equal to negative 4. 5 seconds. 4, 3, 2, 1. What's your solution?
5 halves.
Well, there has to be 2 answers.
Oh.
Or there could be 1. And in this
Actually,
case,
a half.
there's only 1 answer.
It's a half.
The absolute value of any number is always...
Same thing.
No,
Positive or
it's always positive. The absolute value of a number is always...
Positive.
The answer here is...
Oh, so it's something doing zeros.
It's not.
It's negative.
It's no solution.
There's no solution. You cannot have a solution because absolute values can't be
Equal to negative.
negative. It doesn't make any sense.
Equal, okay.
Now, be careful with this. If there's other junk on the left-hand side, don't determine your answer by just looking at the right. Because I could have written the problem this way,
We make it fun.
and just because the other side has a -7 doesn't mean it doesn't have an answer. Because if you add 5, that leaves you with a -2. If you divide by -2, that leaves you with a +1. So it does have solutions. So where this one doesn't have solutions because the other side is negative, after you get the absolute value by itself, this one has solution because the other side is eventually positive. So be careful of that. So if you're in doubt, check your answers. Plug them back in and make sure it works. Because if you solve that green one on top there, and you plugged in your numbers at the end, they wouldn't work. They wouldn't work at all. Which is kind of cool to think about. Okay, what else is there? There is, radical equations.
This is a long one.
Somebody call me.
That's what it sounds like, doesn't it?
You can cry for me.
That's a pitiful cry. Something happened.
Mhm.
That's a death cry right there.
Mhm.
Her father passed away. That's it. I hate bad news.
That's a bit of a cry.
Yes, indeed.
Okay,
More. Yeah,
Yeah,
right.
that's what
They just called her on the cell phone.
I got it.
They just called her and told her while she was at school. Why not come over here?
I
to
bet
the
they.
hospital?
It looks like they texted her. She had her cell phone in her hand.
Oh my God.
I mean, yeah.
That's even
Why?
worse.
You know, show up.
That's even yeah.
That's no single big.
Yeah. By the way, here's a little email your dad.
Yeah.
Not good.
That's terrible.
Of course, there's been teachers here that have been fired through email.
What?
Can I say that?
That's the best way to do it.
Oh yeah, you don't have to be involved. You're fired.
I hate when people do something like that.
It's silly. All right. Edit that little part out. Edit equals X.
If someone could just tell me where radicals fit in everyday life, maybe I can understand
Oh,
it better.
what does any of this have to do with any day's
Some of
life?
it does, but radicals, I just don't. And imaginary numbers, what does that have to do with my
Imaginary.
life?
Oh, don't get me going with imaginary numbers.
Go ahead and waste time.
Okay.
No, we're not wasting time, but they are the reason that those things work. Or lights.
Okay, well,
Or
see,
power.
there you go. There you go.
Okay.
There you go.
And radicals are ways of solving solutions so that you can get answers to things. Without radicals, you wouldn't be able to work with compound interest. Because compound interest has a power. And if you want to get rid of the powers, you have to use radicals of different forms with different indexes. Square roots just happen to be the easiest of them all.
Why can't we just be born with this knowledge?
Go back in time and change our genetic makeup. Remember everything your parents ever did.
Yeah.
No, I don't. think
Well,
I want
Oh, no,
to
no,
do
this is
that.
still 1/6. This is still 1/6. Okay, so if you're given a radical equation, there's really only one golden rule. Golden rule. Isolate a radical, in case there's more than one. The golden rule is get a radical by itself. Get a radical by itself. Kind of like that absolute value equation. Before we could solve it, we had to get it isolated. So the same thing works here. Now, this first equation, it's isolated. It's all by itself. Now, once it's by itself, the object is pretty easy. Take both sides and square it. There's only one thing you can screw up here, trust me. Only one little step. If I square a square root, what happens? They go poof. They do not cancel, by the way, because cancel is inverse and identity, and that has nothing to do with inverse or identity. So you get 7x minus 10 is equal to
X squared.
x squared. Do I need a plus or minus? No, I didn't square root both sides of an equation. I squared it. All right, how do I solve this equation? What's it called first? Let's go through the possibilities. Is it linear? No. It's quadratic or, yeah, quadratic sounds good. I don't know what I was thinking. So how do I solve the quadratic?
You gotta get x squared over.
Keep x squared positive and make it equal to 0. Those are the two things you have to keep in mind. So this side is going to become 0. This side is going to become x squared minus 7x plus 10. I mean, there's parts of this that you should be able to flow through rather nicely. Factors of 10 to add up to 7.
2 and 5.
So we get x minus 5, x minus 2.
Yeah.
So we get x is equal to positive 5 or x is equal to positive 2. Remember that key word? Or it's one or the other or both. Now we have to be careful that one or the other or both here because neither of these answers have to work. And there's a reason for that. If you square numbers at the very beginning, whether they're positive or negative, after you square them, they're both going to become positive. So if your solution turns out to be a positive number equal to a negative number, it makes absolutely no sense. So these you have to check. So 5 has to go back in. 7 times 5 is 35. 35 minus 10 is 25. The square root of 25 is 5. That's my nice little auctioneer voice. And if I plug in 5 on the other side, 5 equals 5. We're fine. Take 2. 7 times 2 is 14. 14 minus 10 is 4. Square root of 4 is 2. And the other side happens to be 2. So that one works. So my solution, and by saying it this way, I'm saying both of these work. They both work.
Are we gonna have to plot these at some point?
Oh my, what, graph them?
Yep.
Without the x, yes.
Do we have to?
Eventually. Not now.
Do we have to?
Eventually. Not now. Are we there yet? Are we there yet? Alright, let's make it harder.
Homework. It's time to
go.
Putting them on there.
I got 5 minutes.
But it takes
my
homework.
class
It
coming
takes,
in.
It takes 5 minutes.
Nah, I gotta show you this one, otherwise you won't be able to do your homework.
Well, good. Go get us homework.
The cool thing is, it's my class that comes in next, so if I'm late, they can't yell at me. Trust me, they don't want to be in here just like you don't. So the more you take up out of their time, they're happy. Okay, golden rule, isolate the radical. So what do I need to do? No. I need to isolate a radical.
Put one on the other side.
Is there a square root on one side of this equation all by itself?
No.
No, so I need to move one of them. The easier one to move is
The 2x plus 8.
that one. So this becomes the square root of 8x plus 17. It's going to equal 3 plus the square root of 2x plus 8. Now before I do the next step, I have to ask a silly question. Oh, let's write it this way. Is this equal to x plus y? Question mark.
No.
Yes, it is.
Yes.
Oh my gosh, if you say yes, I'm really mad.
No.
No.
Why?
Oh, no, I don't.
Square root of 9 plus the square root of 4 squared. Does that equal 13?
No.
No, because the square root of 9 is?
3,
The square root of 4 is?
2,
3 plus 2 is?
6. I mean 5.
Holy humdinger. It's 5. 5 squared is? 25. It's not 13, it's 25. So this is not true. You're trying to mix a rule that is the square root of x times the square root of y squared is equal to,
X plus Y.
well, absolute value of xy, but we won't worry about that. Because it has to be a product. Once plus or minuses come in, you slow down and don't simplify as much as you want to. Pluses and minuses will always slow you down, so don't try to simplify them too much. So when I square both sides here, I have to worry. The left-hand side, not a big deal. The square and the square root will go poof. The right-hand side, though, if I square it, you better write it twice.
Yeah.
Because you're squaring a binomial. So this is 3 plus the square root of 2x plus 8. Okay. And FOIL it all out. So the left-hand side is 8x plus 17. Oops. The right-hand side is going to be 3 times 3.
No.
3 square roots plus another 3 square roots. 3 square roots plus 3 square roots.
Do what?
It's the same.
3x plus 3x.
3 plus, what?
6x.
This 6x, and x in this case is the square root thing. So it'd be 6 times the square root of 2x plus 8. Y'all just don't see little pieces the way I do. This is 3 times the square root of 2x plus 8. This is 3 times the square root of 2x plus 8, which equals 6 square roots of 2x plus 8. Right.
You've been doing this too long.
I know. And square root of 2x plus 8 times the square root of 2x plus 8 is equal to 2x plus 8. Because the square roots just cancel. Yay!
Wait a minute.
What?
I don't understand
I
it
don't know
because
if
you,
you got that
you
6
don't
one.
break things
I
down.
did. 3 times 3.
It's 9.
9, yeah.
3 times the square root of 2x plus 8 is 3 times the square root of 2x plus 8.
Oh, so you already added it.
3 times the square root of x plus 8 is 3 times the square root of x plus 8. 3 square roots of x plus 8 times 3 square root of x plus 8 is 6.
Okay.
Why make it hard? They have the same pieces, so you just have to add the coefficients.
Okay.
You can look back at it. 8 plus 9.
17.
There's a 17 on the other side. What happens to my 17s?
Cancel.
They're going to cancel. 2x on one side, 8x on the other side.
But they add together?
Well, you subtract this one. So it becomes
6x.
6x is equal to 6 times the square root of 2x plus 8. Yay! The golden rule still kicks in.
So you gotta get that 6.
You gotta get rid of the 6. Even if this number does not go into that number, I highly suggest you move it over one way or the other. Divide both sides by 6.
I can't stand it either.
I know. And you get x is equal to the square root of 2x plus 8. Now what?
You gotta square it, right?
Square both sides. And you get x squared equals 2x plus 8. X squared minus 2x minus 8 is equal to 0. X minus 4, x plus 2 is equal to 0. That part you should know how to do. I'm just kind of quickening it up to get to the end. Don't write everything down. You should be able to do that part on your own.
Right.
Now, the important thing is I get x is equal to 4 and x is equal to negative 2. Do they both work?
No.
You gotta
Are you
find
sure?
out.
You gotta find out.
Do I?
If you take 4 and plug it in, it does work. I'll give you that. If you take negative 2 and plug it in, 8 times negative 2.
Negative 16.
Negative 16 plus 17.
It's negative 1.
It'll give you 1.
1.
It'll give you 1. If I take negative 2 here, you get negative 2 times 2 is negative 4 plus 8 is 4. Square root of 4 is 2. So up here you get 1 minus 2. Does 1 minus 2 equal 3?
No.
So this one doesn't work. This one is the only one that does.